Black holes are often described as one of the greatest triumphs of Einstein's general relativity. From the outside, they behave almost exactly as the theory predicts. They bend light, distort time, shape the motion of stars, and create gravitational waves that can now be detected across the universe. But inside the classical picture of a black hole, there is still a problem: the singularity, a point where density becomes infinite, time loses meaning, and the laws of physics no longer seem to apply. This is often presented as if nature itself accepts infinities. But Einstein never saw it that way. He was deeply uncomfortable with singularities, not because he rejected general relativity, but because he understood that every theory has limits. To Einstein, an infinity was not necessarily a discovery. It could also be a warning sign, showing us where our description of nature had broken down. Later, Roger Penrose and Stephen Hawking showed that singularities are extremely difficult to avoid within classical general relativity. But the distinction is important. Their theorems did not prove that singularities are physical objects hidden inside black holes. They showed that under certain assumptions, classical general relativity cannot avoid them. Even today, some of the greatest experts remain careful. Kip Thorne, Nobel Prize-winning physicist and one of the key figures behind LIGO and gravitational wave astronomy, has made the point clearly. We understand black holes extremely well from the outside, but we do not truly know what happens inside. That is not a weakness of science, it is the strength of science, the willingness to separate what we know from what we assume. The event horizon can be studied through its effects. The gravitational field can be measured. Black hole mergers can be heard in spacetime itself, but the central singularity remains beyond direct observation. So perhaps the real question is not whether Einstein was wrong. The question is whether general relativity is complete. Maybe the singularity is not a place at all. Maybe it is a signpost, a boundary where our current theory stops and where a deeper understanding of reality must begin. Black holes may not be where physics ends. They may be where our assumptions end.